Hi everyone, so this is a review for chapter 4 revision quiz. So for this session, we will probably discuss question 4 and we will do question 1, question 3 and question 4, which is the first 3 questions, question 1, question 3 and question 4. Okay, so let's look at question 1. So question 1 asks which of the following is not a valid example, okay? Not a valid example of action and reaction to which Newton's third law of motion applies. Okay? So for this kind of question, we need to understand action and reaction and Newton's third law. Okay? Newton's third law basically says that this is not an exact definition, but you get the idea. If A exerts a force on B, B will exert a force on A. Okay, this is a must, no exception. So we call this an action-reaction pair. And for this action-reaction pair, they have the same magnitude but different direction. Okay, so it's our job right now. For this question, our job will be to find what is object A and to find what is object B. Okay. Then we have to see whether one of the forces is being exerted by A on B and the other force is exerted by B on A. Okay, so let's check it out. So for the answer choices, number 1 is the force of attraction between an electron and a proton. Okay, so for example, for the option number 1, I think we can see A will be your electron, whereas your B will probably be your proton. And they are in an hydrogen atom. So the electron will attract the proton. At the same time, the proton will attract the electron. Okay, so this is a very valid example for Newton's third law because we are able to determine the two objects, and we know that the two objects exert a force on each other, and they are the same magnitude and different direction. Okay, you learn this in semester 2, chapter 1, electrostatics. Number 2. The forces of attraction between two gas molecules passing near each other. Okay, so between two gas molecules passing near each other. So for these cases, yes, it's quite obvious that the A and the B are different gas molecules. Okay, they are not one gas molecules, there's two gas molecules. So A and B are different gas molecules and they exert a force of attraction between each other. You might have heard of this as intermolecular forces, or IMF. If no, you'll probably learn it in chemistry soon. I'm not sure when. Okay. Number 3, forces of repulsion between parallel wires. Forces of repulsion, two parallel wires carrying currents. Okay, so for these cases, the A will be wire, be current carrying wire. Okay, the wire is carrying current. So it's called current carrying wire A. Okay, for B it will be current carrying wire B. Okay, and these two wires are parallel to each other. Carrying wire B. And they exert a force of repulsion. Okay, we will learn that this repulsion will be due to magnetic force, but it's next semester. It will be next semester, chapter 5 on magnetism. Okay, for A and B, for example, for answer choices number 4, the weight of a satellite. Okay, so we know that A will be satellite, weight satellite, and the centripetal force keeping the satellite in orbit. Okay, we should how should we say it? You know, the other object will be Earth, but here's the problem: the weight of the satellite. It's exerted by the Earth. Okay, it's a gravitational pull by Earth on the satellite. Whereas the centripetal force is actually equivalent to the weight of the satellite. So these two forces are exactly the same. Okay, you can call it different name of the same force. I cannot explain in detail for you because this is in chapter 6, which is right after work, energy and power. That chapter we'll learn uniform circular motion, so we'll learn a bit about centripetal force and weight. So basically for this option number 4, the centripetal force is exerted by the Earth on the satellite. The weight is also by the Earth on the satellite. So in this case, we cannot find any the other opposite force. Okay, we cannot find the reaction force. The reaction force should be a force exerted by the satellite on the Earth, but we don't see that this force is being mentioned. The two forces being mentioned are weight and centripetal force, but they are exactly the same thing. They are not action and reaction pair. They are exactly the same thing. So in this case, there is no action-reaction pair, so this is not a valid example. Okay, this is for question 1. Question 2. Suppose that a skateboard is accelerating at the rate of 2 meters per second square. So we can know the first information that they give is 2 meters per second square. If the net force is triple, means by the new net force, we call it F prime, is 3 times the original net force, and the new mass is half of the original mass. The prime here means new. New condition or new situation. Okay, it's the apostrophe, okay, that we usually use, prime. So they ask for what is the new acceleration of the skateboard. This is the old. If you have prime, then only it's new. So they ask for the acceleration. We know that acceleration, the new acceleration will be the new force divided by the new mass. And we know the new force is 3F. The new mass is half m. So we know this is equivalent to 6F divided by M. But we know from this F equals to MA, we know that A is F divided by M. This is the old acceleration. So now we can know that the new acceleration is 6 times the old acceleration. And since we know the old acceleration is 2 meters per second square, so we can put in this 2 meters per second square and we got our answer as 12 meters per second square. So the answer is 12 meters per second square. It's an acceleration. I'm supposed to have square here. There's a problem with this question. Okay. Next. Question 4. Many people are familiar with the fact that rifle recoils when fired. The recoil is a result of the action-reaction force pair. Action-reaction force pair. Gunpowder explosion creates hot gases that expand. Okay, hot gases expand, allowing the rifle to push forward on the bullet. So we know from here that rifle exert a force on the bullet, okay, by the rifle on the bullet, consistent with Newton's third law of motion. The bullet pushed backwards upon the rifle. So this will be bullet exert a force on the rifle. Okay, and they say this is in accordance to Newton's third law of motion. So we know that they should be same magnitude, opposite direction. Knowing that, we can safely say that F by the rifle on the bullet is equals to the force by the bullet on the rifle. Okay, we are talking about magnitude here. We have the same magnitude, so FRB will be equals to FBR. Okay, since this is by rifle on bullet, this is by bullet on rifle. Okay, so we know that for the left hand side, this will be equals to the mass of the bullet. Okay, the one experiencing the force is the bullet, so it will be moving the bullet because the bullet is experiencing a force, therefore it accelerates. Acceleration of the bullet, not the rifle. The one experiencing the net force here, it's by the rifle on the bullet, so the bullet is experiencing the net force, therefore it's the bullet that will accelerate. Okay, for the right hand side of the equation, it's by the bullet on the rifle, so the rifle will be the one receiving the force, experiencing the force, therefore it will be the mass of the rifle times acceleration of the rifle. Okay, so we know that the mass of the rifle is much greater than the mass of the bullet. the bullet is very small, very light, whereas the rifle is more massive in comparison to the bullet. Knowing that, we know that MR over MB will be greater than 1. Okay, so if we know that MR over MB is greater than 1, we can know that because of this, I can know that acceleration of the bullet divided by the acceleration of R will be greater than 1. Okay, it's a matter of substitution here. And from here I can know acceleration of the bullet will be greater than the acceleration of the rifle. So they ask for the acceleration of the recoiling rifle. Acceleration of the recoiling rifle will be smaller than the acceleration of the bullet, and this corresponds to this. The acceleration of the rifle is smaller than the acceleration of the bullet. Okay, so this is how we solve ratio question, by listing down everything we know and do a comparison by taking a ratio. It's a bit difficult, but with practice, you know how to construct the equation as accurately as possible. So that's all for chapter 4 review of revision quiz. Thank you.